Hello and welcome to this R tutorial. So today we're going to implement our second nonlinear regression model. It's going to be the SVR support vector for regression. So let's do it. We're going to use our regression template and you're going to see how it's going to be so easy. So let's start by doing the basics. Set the right folder as working directory. So we'll go to machine learning AZ, part 2 regression, and then support vector regression. Right, that's the right folder, position salary CSV file, all good. Let's click on set as working directory to set the folder as working directory. Great, and now we can start. So we're going to take our regression template and we're going to take everything from here to here, copy, and paste it in our SVR model. Here we go, and now we just need to change a few things. So let's start by changing the basics. We're going to replace regression model here by SVR. Okay. And same here, SVR results. Okay. And same here. All right. That was the easy step. And now let's get to the interesting step. So this interesting step is of course to create our SVR regressor. And we are creating it here. So I'm going to remove this. And now let's create this regressor. It's going to take 3 or 4 lines as usual. It's going to be very simple. We're going to use a function, which is the SVM function, very simply, because the SVR, you know, is a support vector machine algorithm, but for regression. That's why we call it SVR. And therefore, we're just taking it from the SVM function, and you will understand why perfectly. So first, let's import the required package, because this function is contained in a package, which is the E1071 package. So let's go to our packages here and let's check if we have it. So I have it because of course I used it before, but you might not have it. So in case you don't have it, I'm going to type this line here that you will need to execute to install this package. So you type install that packages here, and then in the parentheses and in quotes, you type the name of the package, which is E1071. Alright, and then you just select this line and execute, and this will install the package. I'm not going to do it because mine is already installed, and therefore I'm going to put that in comment. I just pressed Command plus Shift plus C. Alright, and now let's actually also add this line, library, and in parentheses E1071, not in quotes, and this will select automatically the package here, E1071, because this will not always be selected. But by including that in your script, you will be all fine. This will always be selected. Okay? And now let's start creating our SVR regressor. So as usual, we're going to start by defining our regressor, and then equals. And then, as I mentioned before, we're going to use the SVM function, which is actually this, and then in parentheses. So now let's press here F1 to have a look at the arguments and see what we need to input. So the first argument is formula. So you start to know perfectly what it is. Of course, the formula is our dependent variable, which is, remember, salary, and then tilde. I just pressed Alt N, and then a dot here. And the dot specifies that we are taking all the independent variable of our data set. We actually have one independent variable, which is the level independent variable. So we could also type here level, but most of the time we use the dot because of course we have a lot more than one independent variable. But as a reminder, I'm taking one independent variable here so that we can clearly see the visual graphic results of the different nonlinear models that we're building. Okay, so now let's add the second argument. So I'm adding a comma here and then next argument. So the next argument is data. Okay, I guess you know what this data argument will be. It's going to be, of course, our data set. Data set here because we did not create any training set or test set. You know, before we used the training set here as the data, but here we don't have any training set, so of course we're going to take the whole data set because we want to make very accurate predictions. Okay, and now, finally, most important argument. Well, all the arguments are important, but the most relevant for this section about SVR is actually the next argument we are about to input. So this argument is actually not X or Y, these are optional arguments. The most important argument I was just talking about is this one, the type. Because this argument type will actually specify if you're making an SVM model, which is used for classification, or an SVR model, which is used for regression. So here, since we're building a nonlinear regression model, we will choose the EPS regression type. We could choose actually EPS regression or new regression, but as you can see, we want to take the most common one, the EPS regression. And if we were making a SVM model for classification, then we would have chosen C classification here. As you can see, C classification is the default type for classification. So in short, if you want to do regression, you choose type equals EPS regression. And if you want to do classification, you choose type equals C classification. And actually, in the next part about classification, we will make an SVM model. And for this specific model, we will choose the C classification type. Okay, but here we are doing regression, so we choose the EPS regression type. So let's input it. I'm going to type here type equals EPS regression. All right, and you need to put that in quote, actually. Don't forget the quotes to prevent any error from happening. Okay, and that's actually the final argument. If you want, we can add the kernel argument here, just to specify that we want the Gaussian kernel, because here we're using a Gaussian kernel, but it's the kernel selected by default here, so we don't actually need to input it. But just keep that in mind that we are here using the Gaussian kernel for our SVR model. Okay, but here we're all fine, and actually our model is ready to be created. So actually this is all we had to change in this regression template, and now we are ready to execute the sections one by one to create our model and find out about the final result and the final verdict, whether it's truth or bluff. So let's do it. I'm going to import the dataset first. All right, here we go, well imported, we can have a look. So these are our dataset with the levels as the independent variable and the salaries as the dependent variable. Okay, great. And no need to split the dataset into the training set and the test set. No need for feature scaling because we're using the very popular E1071 library that includes it. And now let's create our model. So I'm going to select this whole section here, press Command and Control plus Enter to execute. Done, regressor created. Great. And now let's predict the new result. Would you like to start by visualizing the SVR results first or predicting the new result? Well, let's actually predict the result because this is the most exciting step, and let's keep the best for the end. But this step is actually very exciting also because we're getting the final prediction, we're getting the final predicted salary. So, you know, it's as you want. If you're doing actually this code by yourself before me, that's actually a very good exercise. So I really encourage you to do this. Choose whatever you want to execute first. It's ready anyway. You don't need to change anything more now. So I'm going to execute that right now. And actually we obtain a predicted salary of $177,000. Great. So remember, this employee who we are negotiating the future salary right now said that its previous salary was 160K, and our model predicted that its previous salary was 177K. So first of all, that's actually close to what this employee said, and besides, it's on the good side of the negotiation, so that's actually pretty good, and we can be satisfied with this result and our model. But to be really satisfied, let's see what's happening with the graphic results. So I'm going to execute this section, and let's have a look at the SVR model. And here it is. I'm going to zoom on it, and better. Okay, so first of all, this model fits very well most of the data points. As a reminder, the real observation points are the red points here, and all the points in this blue curve here, which is the SVR model itself, are the prediction points. So for example, if we're taking this red observation point here, well, the prediction is perfect because the prediction point is the projection of this red point on the blue curve. So it's actually the red point itself because the red point is on the blue curve. So that makes a perfect prediction. But here, for example, if we take a less accurate prediction but still a very good one, then we take the real observation point here, the red point, we project it on the blue curve, and that's the difference between the real salary and the predicted salary, which is here, if we project it back on the y-axis, which contains the salaries. But you can see that for all of these points from this one to actually this one, the blue curve is actually getting very close to the real observation points, the red points, and so the predictions are very close to the real results. But that's for all these points of the data set, except for this one here. This one is left alone, which, by the way, corresponds to the CEO. So I'm sorry for the CEO, but the reason for what is happening here is that this is actually an outlier. Not to call the CEO an outlier, but this is an outlier because, as you can see, this point is actually far from the other points in terms of salaries. The CEO has a much higher salary than the previous positions. So for the SVR model, that's an outlier. And therefore, he actually didn't consider it. It's like it excluded this point in the model by not looking at it and making its predictions on these points here. So that's specifically due to the SVR algorithm itself, but there are a lot of parameters, and you can actually play with the parameters to change the way the SVR model perceives outliers. So for example, these parameters are the penalty parameters, the regularization parameters. It's most of the time well described in the description, and of course the E1071 library includes such techniques. But we're not going to do it here in this tutorial because we actually don't need to get a good prediction of the CEO salary. And remember, what we actually needed was a good prediction of the previous salary of this employee we're negotiating with. And this employee has a level 6.5. And around this point, we can see that the SVR model fits very well to our data set. And we actually get a prediction of 177K, quite close to the real or the mentioned salary of this employee, which is 160K. So that's actually pretty good, and therefore the verdict of truth or bluff according to our SVR model is rather truth. Okay, so not bad. The SVR made a good job here. Now let's see how decision tree regression and random forest regression will do. We'll see that in the next sections. So I'll see you there, and